teeny bit earlier so that we know that you're here, somewhere in the front. We can do the whole switcheroo pretty quickly. That would be really, really great. Reminder, everyone who has coached or has organized the Rails Girls workshop before, please join me in the front during the little break so that we can take a picture. Our next speaker is Pan. He leads the productivity engineering and the Ruby, Rails, and JS platform at STRAVA. He loves developing automation to reduce the amount of manual tasks that we have to do. I mean, don't we all? And he ran into a really weird bug the other day, and trying to solve it, he ended up in the middle of rec middleware. There's water for him so he can start. Pan.
Thank you. Thank you. So I'm going to share a little bit of this adventure that I went on with you, and hopefully you will learn a little bit about rack, just as I did along the way. So for those of you that are in the far back and can't see me, if you want to find me afterwards, I look like this, but my beard is now a little bit longer than it was in this picture. And I'm not wearing a button-down shirt. So I work for a company called STRAVA. We are a social network and training log site for athletes. That means that you might go on a run or a ride and upload like a bunch of GPS data and power meter data and heart rate data to our site. We will let you dig into that data and like find cool things about yourself and compare it with your friends and your past performances and find a lot of interesting things about yourself in your running and cycling. So I want to talk about a double refresh bug that I found. I'm calling it a double refresh bug. I'll explain why in just a moment, in our Rails application. So we have this screen in our Rails application that allows you to change your display preferences. So as an athlete in Europe, I might want to see things in kilometers and kilograms. If I live in the United States, I might want to see things in miles and pounds. And the way this bug works is, it's already running. So give it a moment here. Here we go, it'll start again. So there's kilometers and kilograms. I go to this drop-down, and I want to select miles and pounds. Maybe I'm going to go to the United States. I want to get used to this measurement preference. And when I click Save, there's an AJAX action that hits the server and persists that. But when I go to refresh the page, the value flips back to kilometers and kilograms. And then when I refresh the page a second time, hence the double refresh, the value actually goes to miles and pounds. So what is going on here? So my first reaction at this point was like, I want to find out if this is like impacting the database. Am I actually like persisting the correct value? Or is this just a code issue, right? So I want to kind of like narrow down the possibilities here. So I wrote this query. I hit the database. The database is like, you are sane. This is actually getting persisted properly. The value is feet. So I decided to dig into the code. And we have this settings controller. It fronts all of these display preference views. And there's an athlete method on that controller. It takes a current athlete. You're only allowed to modify your own preferences, not somebody else's. It wraps it in this sort of permissions decorator. It's not particularly important, but it exposes that athlete to the rest of the controller methods, right? So this is sort of the object that we're operating on. So I dug into my debugging toolbox, and I pulled out pry. I love pry. For those of you that are unfamiliar with it, it is like IRB, but just with a lot of cool additional functionality. One of my favorite pieces of functionality that it provides is that it allows you to call pry on Ruby's binding object. And that means that when you hit that point in your code, it acts like a breakpoint, and you get to interact with the code in real time, as if you were like modifying the code. So I went into my athlete method, I put a binding.pry call in there, I refreshed the page, and I ended up in this cool interactive console. And the console tells me exactly which file I'm located in, the particular line that I'm on, the controller name, and the method that I'm running in. And it also gives me a neat visual display of exactly where I'm located in that method. And the coolest part is that I actually get to interact with the code with this console. So I said, okay, tell me what the measurement preference is for the current athlete. And it said the measurement preference is meters, and that's incorrect. I was switching to feet, right? So that's not the correct value. So I was like, okay, let's use active record instead. Let's query the database directly. Let's use that same athlete ID and figure out what that says. And it said the value is feet. So what is the difference between current athlete and athlete.find? So to figure that out, we look at the method definition for current athlete. It's defined on application controller. There's two ways to log in, either from a remember cookie, which is kind of like a long-lived session, or just from the session, like the current session cookie. I happen to know I'm using the current session because I am actively interacting with the website. So I'm going to dig into that method next. There's a bunch of code in there, but the important stuff is that I'm using the session ID from the cookie to figure out what my athlete ID is. I'm using this athlete.fetch method, which I will come back to in a moment, and then I'm storing the result in an instance variable so that I don't have to do this operation again. So before I actually dig into what athlete.fetch does and why it's different from athlete.find, let's go back to our interactive console and figure out how it behaves. So as you recall, I have this disparity between the values that I'm getting here, and I want to know what happens when I fetch the athlete as well. And when I do that, it turns out I get meters. That's also the incorrect value. That's the value I'm getting for current athlete, but it's not what's in the database. So let's take a look at the method definition. So this is an active record object. It's called athlete. The fetch method has a very simple API. It takes an ID, just like the find method does, and then it passes the active record object itself and that ID off to this entity map thing. So what is this entity map fetch thing? In particular, what is this entity map? And it turns out it's a request level cache, which means that if I use this cache to request an object by its primary key, if I already have that object in memory, I'm going to use it. I'm not going to go to the database to get it. So at a kind of an abstract level, this is how it works. There's a request method. I can give it an active record object, the entity, and a set of primary keys. And that means I don't need these things quite yet, but I'm going to need them later. So you don't need to go to the database to get them yet. The way it works is we generate a cache if we don't already have one, and then we ask for those primary keys from that cache. And then there's a fetch method. This is sort of like the eager version. You give it a single primary key, but it will go to the database, get all the requested primary keys and that new key, store them all in cache, and just return that single one that you asked for. And it works in a similar way. It uses that same cache, generates one if one doesn't exist, and fetches that ID for it. And obviously, we need a way to clear the cache. We can clear the cache by running this clear method. It clears all the caches that we have in memory. So let's see how this behaves. Remember, I ask for something with fetch. It gives me the incorrect value of meters. And then, so what happens when I ask for something, and when I clear the cache and then ask for it again? Turns out I get the correct value. So this obviously works in the console. So why is this not working in my web requests? How do I actually clear a cache in a web request? So like how might you actually go about clearing a cache for every single web request? So what I know for sure is that each request needs a fresh cache. And for me, every time I hear this phrase, for each request, I immediately think of rack middleware. How many of you were thinking of that? So before we continue with the debugging story, let's take a slight detour and talk about rack. So for those of you that are not familiar with rack is a minimal interface between a web or application server and your Ruby application that speaks HTTP. So you might have things like Puma, Unicorn, those are web and application servers, and on the other side of the spectrum, you have maybe frameworks or like real Ruby applications like Rails or Hanami or Sinatra. And rack sits between these two things, and it allows them to communicate. So I can front a Hanami application with Puma, or I can front a Rails application with Puma. It doesn't matter. They all speak rack, so they're all interchangeable, except for your actual business logic, obviously. So what does rack actually need to make an HTTP response? What do we actually need to tell the browser? So we definitely need a status code, like 200, okay, 404, I didn't find this thing. 500, stuff blew up, I don't know what's going on. Headers, I need headers, right? I need to be able to tell the browser that the content type of what I'm sending back is JSON or it's HTML or something like that. And then I also need the actual body of the response, right? The actual content, the JSON, the HTML, the image. So rack represents this as an array of 3 elements. The status is the status code, the headers are the hash of headers, and the body is the actual content that I'm sending back. Here's an example of that. In this case, this is a 200 response, everything's okay. I'm also sending a hash back that says that the content type is JSON, so this is a JSON string, you can JSON decode it. And then I'm taking a hash, converting it to JSON, that looks like a string, and I'm sending that back as well. For the astute observers in the audience, you may have noticed that this thing has these like square brackets around it, which means it's an array. So why is that? Why is this an array and not just a string? The reason is that rack can actually accept a series of things. And in fact, I don't need to pass an array to rack. I just need to give it something that responds to each, something that's sort of enumerable. So the reason for this is that the rack handler, which actually speaks to the application server, iterates through each element of that body and adds those elements to the response. So I can specify like the major components of my HTML element as separate elements in an array, or I could create an object that responds to each, that yields each element in turn. Any of these things will work. This is useful for buffering and for streaming. So you could imagine a future in which I send the header part of my HTML element to the browser. It can start prefetching content while I'm still streaming or computing the body of my response, right? But that's it. That's the basics of rack, status, headers, and body. There's also the other thing that I mentioned, which was the middleware part. So what is middleware? So we have a rack handler that's talking to our server, and we have our Ruby application on the other end. Rack middleware basically sits between these things, so that when I receive a request, the rack handler processes that request, it turns it into an object, it sends it off to the first piece of rack middleware, which sends it off down through the chain of rack middleware all the way to the Ruby application. We do our business logic stuff, we query the database, and then we send that back up through the middleware stack to the rack handler. The rack handler sends out a response. So let's write a piece of rack middleware. Here's my timer middleware. It's going to tell me how long a request took to process. So I initialize it with an application, and that could be my Ruby application, or it could be another piece of middleware. It doesn't really matter. I have to respond to this call method. The env param you can think of as basically the request. At the beginning, I'm going to use this timer thing to keep track of what the current CPU time is, and then I'm going to use that original application to send the request off to, and I'm going to track the response of that. Once I'm done with that, the responses come back to my particular piece of middleware. I'm going to figure out what the CPU time is now, and then I'm going to display the difference between the start time and the finish time to standard out, so I know how long this request took. At the very end, I'm going to return that original response that I got back from the other piece of middleware, so I'm not modifying it in any way. So the way I would use this is I'd go into a config.ru file, and I'd say use my timer. If I was in Rails, I'd use this like longer syntax in an initializer. They do the same thing. So locally, I would curl this, and I'd get some standard output that says, okay, your request took 100 milliseconds, for example. Great. The problem is, as we talked about before, the rack handler iterates through each part of my body to generate the response. And the issue with my particular piece of middleware is that all happens after I've returned, right? So I'm not accounting for any of that iteration in my timing. So that means that if someone gave me a really, really slow response, a really slow body that like slept for 2 seconds, I would not account for those 2 seconds in my timer. So how do we know when our response is actually complete? How do we know when we've actually iterated through each one of those elements in the body? So rack has a pretty cool solution to this. It's called the close method. This is sort of what a rack handler looks like. When it's servicing a request, it sends that request off through the middleware stack, it iterates through the body, and then at the very end it has an ensure block. And that ensure block, after it's iterated through the entire body, calls close on the body as well. So how do I adjust my middleware to take advantage of this? Because this timing is not working, right? Because I'm not accounting for that each part. So this is a body proxy. It's the classic solution to this problem. It's initialized with a body, which is the body that I'm proxying for, and a close block that I want to run when the close method is called. The each method is delegated to the original body, the body that I'm proxying for, and the close method, it still calls close on that original body, but it also runs that close block that I was initialized with. So here's like a super simple example of that. Here's a body proxy, it wraps the original body proxy, and then it prints to standard out, okay, now the response is like really done. I'm serious, it's done now. So here's how I would use it. Instead of just getting a response from the next piece of middleware, I would actually destruct the response into the status, headers, and body. I would wrap that body in a body proxy that had that code that says, okay, now the request is really done. And then I'd return the status, the original headers, and the new proxied body. So my body gets wrapped along the way, and when proxy actually gets called, my code runs. So let's adjust my timer middleware to take advantage of this fact. I'm going to start the timer at the beginning, just like we did before. I'm going to destruct the components of the response, and then I'm going to wrap that original body in a body proxy that does the finishing part of the timer, right? And then at the end, I'll return the original status, the original headers, and my new proxied body, so that when close is finally called, the finished stuff runs, and I get my output. And I get to account for that really slow body response, and my timing actually like fully works. So this is actually such a common pattern that Rack provides a body proxy out of the box. You can use this one, or you can write your own. This is slightly more complicated, but it effectively accomplishes the same thing. So for the visual learners, here's what it looks like. You have that Rack middleware. You get a request. Goes all the way down to the Ruby application. That Ruby application is actually generating a body. That body can either get passed back up or proxied along the way through the middleware stack. The Rack handler says, here's the final response. When it's done doing that, it says, hey, that body that I got, close. And then that body's responsible for passing that close call down through the stack again. So that's Rack and Rack middleware, the basics of it. Back to our bug. I have this weird display preferences thing. I have to refresh the page twice to get the correct value from the database. I have this athlete object that I have a binding.pry call in. I've narrowed down the issue to this entity map thing. And I know that the entity map clearing actually works in the console, but I don't know where the entity map clearing happens in my web request. So as it happens, when we migrated our Rails application from Rails 3 to Rails 4, we had to get rid of this thing called the identity map. The identity map was a request level cache for Active Record. We transferred a lot of that work to our entity map. We like our entity map more. It's a little simpler. It has some additional functionality that we like. But a lot of the basics came from this identity map. The way the identity map worked is that it had a piece of middleware. And that piece of middleware had a call method. And that call method used the body proxy. That body proxy had a bunch of code in it. The most important part was the close method. The close method had an ensure block at the very bottom that cleared the identity map when the request was done. So this is how the identity map was cleared in Rails 3. In Rails 4, we have our entity map. And we have a similar piece of middleware. It also has a call method. It also has a body proxy. That body proxy looks a lot like the previous few slides. It has a close method, and in the ensure block, it clears the entity map. So when the request is fully done, everything's iterated through, we call close, the entity map gets cleared. So, handy toolbox, binding.pry again, probably use this almost every day. Go to the close call, put a binding.pry call in there. Let's refresh the page, let's try to reproduce this again, and nothing happens. Like, there's no interactive console. I guess my code's not getting called, right? So maybe binding.pry is failing me. Let's blow things up. Let's make sure the application like fails for sure, right? Maybe there's some weird thing going on with the terminal. Refresh the page, nothing happens. So at this point, go to GitHub and start looking at Rack code. Like, you have to understand Rack fully, right, to figure out what's going on. Almost, but the problem is whenever I want to go look at source code, I always run into this question, which is what version of that gem am I actually using, so that I make sure I'm looking at the correct code, so that I make sure I'm actually fixing a bug and not like looking at someone else's unreleased code yet. So my favorite way to answer this question is the show command that Bundle provides. You pass it a gem, and it tells you where on your actual system that gem is installed, where the code that you're actually running is. And that happens to also tell you the exact version that you're running as well. So I like to go into that directory and like start poking around. So for those of you that prefer using an editor to navigate files, you can do that with the bundle open command as well. I like to use Vim to poke at the files and run commands, so I do this instead. So anyways, I'm going to open up this WebRec handler, and the neat thing about it is, as we looked at this before, again, it's that servicing a request. I pass that request down through the middleware. I iterate through the body, and I have that close call, right? And I'm interested in this close call. I'm interested in maybe putting a binding.pry call in there, which is at the very end of my request, to make sure that like Rack itself is actually behaving as I expect it to be. So I did this. I went to that settings page, and I'm clicking on that drop down. I'm selecting this value, and then I'm like doing that Ajax action, right? That actual save. And at this point, yay, I actually got an interactive console. So Rack is behaving properly. So while we're here, let's take a look at this request. Let's figure out what it actually looks like. So we're going to ask Rack what the body is, and prepare yourselves. Boom. Lots of stuff. So bear with me here for a moment. We'll walk through this. The first thing is a body proxy. It has a block and a body. The block is something that was defined by like rack lock. It doesn't particularly matter, but its body is also wrapping another body proxy. This one is a action dispatch one. That has a block and a body. The block happens to be coming from middleware reloader, and its body happens to be wrapping another body proxy. That body proxy also has a body, and that one's wrapping a query cache body proxy. At the very end, finally, that query cache body proxy is wrapping my JSON response. So my JSON response is there, but that full list of body proxies all the way down is missing one particular element, right? My entity map middleware body proxy is not there. So where is it? Well, it's sort of expected, I guess. This is a double refresh bug, and I just did the Ajax action. So let's exit. Let's refresh the page. Let's go to the next interactive console, right? This is the HTML element now. The HTML page that I'm loading. I've just refreshed the page. Let's see what the body looks like in this case. Big blob of text again. But at the bottom here, you can see that same query cache body proxy, and this time it's targeting my actual HTML page. But again, when you look through that middleware stack, that middleware body proxy stack, my body proxy is missing. So this was the first refresh. We need one more refresh, right? So I'm going to exit here. But before I get a chance to refresh, I'm thrown into this interactive console again. And I haven't made a request to the server. So at this point, I was like, what the fuck is this request? Right? What is going on? Like, I have not refreshed the page. Okay, so let's ask Rack, like, what is this? And Rack's like, this is your application CSS. Oh, yeah, that's right. You know, I make the browser request, and then the browser's like, give me all the JavaScript, give me all the CSS, give me all the images, blah, blah, blah. So I forgot about that. Let's take a look at the body while we're here. So we take a look at the body. There's that query cache body proxy at the bottom. But this time, it's targeting my entity map middleware body proxy. And in fact, this was the case for all of the asset requests that followed. There's a lot of asset requests in development, by the way. So why is my middleware not present in those Ajax and HTML requests? And why is my middleware present in the asset requests? So I can use binding.pry again, but actually I have another theory. There's this cool command called rake middleware or Rails middleware, depending on the version of Rails that you're running, and it prints out a whole list of like all the middleware you're using in the exact order that you're using it. So at the very bottom there, there's my STRAVA application. Right above it is my entity map middleware. Higher up in that stack is that query cache thing we kept seeing. And my theory is that between these two, between the entity map middleware and the query cache, some other piece of middleware is messing up my stuff. Like there's some other thing in here. And there's not a big list. I think I can search through these. So what I'm going to do is I'm going to pick the first one above mine, and I'm going to use this insert before call. And I'm going to stick it in an initializer, and I'm going to say, I want my entity map middleware to run before that other middleware does. Because if that other middleware was messing me up, I will at least get a chance to beat it to the punch. So I'm going to go from my middleware stack looking like this to just moving my entity map middleware up one. Refresh the page, and the bug is still there. I didn't resolve it. No, nothing to do. Okay, brute force, though. We can do this, not too many to go through. Let's take a look at etag. We're going to insert the entity map middleware before the rack etag middleware. We're going to go from a stack looking like this to just popping my entity map middleware up one. We're going to refresh the page, and the bug is fixed. It's gone. That was actually the easiest brute force I've ever done. Second time around. So what is rack etag, and why is it messing up my stuff? So we're going to go into rack etag. We're going to poke at the middleware and see like what the code's actually doing. So this is what the call method looks like. And it looks like a standard piece of middleware. It destructs all the components of the response that it gets back. And then it has some conditional that says, is this an etag type of thing? If so, I'm going to create a digest of the body and add that as a header, an etag header. And then we can skip the rest of that stuff. We're going to return the status, the headers in the body. So what is this digest body thing? It looks like this. It's a private method. It has a parts array. We iterate through the body, and we add all the parts to the parts array. We join them up to a string, and we create this MD5 hex digest that we return along with the parts. But as you may have noticed in this entire thing, we iterate through all the parts of the body, but we don't do anything with the close call. There's no close call there. And in fact, we create an array of parts. We add all the body parts to that array. It's gruesome, but all the body parts to that array. And then we return the parts at the very end. So my close call is missing from that. And in fact, when I look at the middleware call, the call method, I'm replacing the original body with the digested parts from the digest, and I'm returning those instead. So my close call is totally missing. That is why my middleware is not getting cleared. That is why I have this double refresh bug in the first place. In fact, if you comment this conditional out, the bug goes away. That sort of confirms my hypothesis, right? And if I actually check on rack master now, I actually go to GitHub, go to rack master, and there's an expanded conditional. It has a body proxy, and that body proxy has a close call. That particular line of code was added in this commit. Very descriptive. Bug is actually fixed there. So what's next for me? What do I do? What do I do after this? So first of all, I have a lot of binding.pry calls and like commented out code in the rack source code. So I want to restore that to its original state. And this is a great command for that. It restores a gem to the state in which it was if you had just downloaded it from Ruby gems. My next option is I could update rack, right? I could just use a newer version of rack that has this fix in it, and then the problem maybe goes away. I could also insert my middleware before the rack etag middleware and just bypass the problem. Maybe I'm stuck on a particular version of Rails that is using a particular version of rack and I can't update it yet. I could also take a totally different approach. I could change my entity map middleware to instead of using a body proxy, it could just clear the cache before running the request, right? This effectively accomplishes the same thing. I have a totally clear cache, and then my request runs. So I have a lot of options. And at this point, especially when I have a lot of options, it's nice to kind of like take a step back and think about things. So here's what I thought about. I was like, is the rack API sort of like weak? Maybe that's not the right word, but it's not like telling me what the correct solution is here, right? And maybe is the rack API, maybe a better way to think about it is that rack API like error prone, right? Certainly I can write malicious middleware that will break an application, that's for sure. But it's also very easy to imagine myself writing that same kind of middleware that forgot to make the close call on the body. So it's certainly error prone to forgetful middleware. And then I was like, is the rack API just kind of weird? And by that I mean, is it actually Ruby-like? This like array of 3 elements is not something I would expect from a Ruby API. I would at least expect something like this, a hash. More likely I would expect an object with methods that I could actually call, right? Not an array of things. But the array is actually quite easy to work with, as we've seen, and it's simple, it's probably pretty fast. I think the real issue is this close call. And the issue with the close call is that the body is responsible for the each call and the close call, and sort of like optionally the close call, right? Because in most cases, we don't call that close call unless the body actually responds to it. And each is actually part of the HTTP response, the thing that I'm sending to the browser or the API, and close is part of the request lifecycle. And these are 2 very different responsibilities that fall to that same body object. So let's just split them up, right? We'll put a 4th element in the array. That's going to be my close block, and then problem solved, right? Definitely not backwards compatible. That would probably break a lot of applications. So there's also another issue with this, which is that I run into the same problem, right? The first 3 elements of this array are responsible for the HTTP response, and the last element is part of the life cycle. And the other issue is that that last element, just close, it kind of ignores other life cycle events. If you think back to my original timer, I had something I wanted to run before the request. I had something I wanted to run after the request. So maybe what I need is a more full like ecosystem syntax, like something that I have in RSpec, right? Where I can run things before all the middleware or after all the middleware, before a particular middleware, after a particular middleware. And Rails actually has something similar to this. It's called action dispatch callbacks. You can say things like, I want you to clear my entity cache before the request. I want you to start a timer before the request, that kind of thing. It's Rails only, obviously. That's problematic. And there's no order dependency in that API. I can't say that I want my timer to run before my exception tracker or my exception tracker to run before my timer unless I define them in a particular order. But even then, I can't impact any of the middleware that a third-party library installs, any of the middleware that Rails already comes with. So here's another idea. Let's add order dependency to the rack API itself. Maybe I could say I want my entity map to clear before my application runs, right? Maybe we don't like this anonymous block syntax. You could think of another approach. Maybe we have methods on our middleware that can be called that I can run something before a request and I can run something after a request. I kind of like this idea. This is sort of where I ended up. I like this idea of hooks that kind of manage that underlying middleware complexity for you. I think it's something that's probably backwards compatible. I like to call this idea middleware light. It's like the easy version of middleware. If any of you have rack commit access, maybe it's something you could include in rack itself. Maybe if I have extra time, I will create a pull request. Anyways, this is where this story led me. It led me to thinking about, like, if I had complete control over the rack API, how would I adjust things so that the responsibilities of objects were more clearly indicated by those objects? And yes, we did solve the double refresh bug. We actually, in our application, we ended up going with the approach where we clear the cache before the request runs entirely. We thought that was the simplest approach. So that's all I have for you today. Thank you. My name is Thomakos.
It's break time. So please be back at 3:15 for the lightning talks. Lightning talk holders, speakers, please come to the front.